subject, it is rather a hybrid, a combination of traits from multiple subjects, okay, wherein you work on processes and systems to extract knowledge or insights from data, okay, in various forms. Either they are unstructured or they are structured, which is again a continuation of some of the data analysis fields, such as you already do a lot of predictive modeling in statistics. Okay, statistics is used in a lot of predictive modeling. You already do a lot of analysis using machine learning algorithms, data mining algorithms. So, but this field encapsulates everything. When you talk about data science, it will encapsulate everything. You can call it as a domain, as a superset of all that is covered here. So it's a very generic term, uh, covers a lot of uh, topics from multiple subjects, multiple fields, okay, and this is similar to what used to be done in knowledge discovery and databases. I hope some of you might have heard this term earlier. So there is a knowledge discovery and databases cup, also KDD cup it's called, and it's a very prestigious competition among data scientists. So people fight for that prize money, and the problems are real life machine learning problems, wherein the data set is provided and you have to come up with your smart algorithm which reduces the error on the test data. So the KDD approach is carried forward when you talk about data science. So it's not just that you will be focused only on statistics or machine learning or data mining. You will be doing everything that can bring up any insight into your data, anything valuable from your data that you can leverage to your benefit, to your advantage. Okay, so is it a brand new discipline? I won't say brand new discipline because it's a hybrid discipline, but yeah, it's relatively new compared to the other core disciplines: statistics, physics, biology, mathematics. So it's relatively new, and the hype or uh, what expectations are there when you say I'm a data scientist? What are the responsibilities that come with it? So I've displayed a word cloud here. I hope all of you know what a word. So if you take up a document or any word file or any text file, and if you try to find out the number of times a term is appearing in that file and give a count in front of that. So okay, if I try to, there is a keyword and there is a count here. Okay, so if I arrange this and I try to give a picture for it in the order of size of the word, as a bigger size, it means it appeared the most number of times. So if I plot such a graph for you, a word cloud for you, you will see the data science term appears most. If in any document or any reference or any article or any web page that you're talking about, you also see data mining coming up, analytics coming up, machine learning, computer vision coming up, KDD coming up, visualization coming up, but you see a lot of times the term data science being referred. Okay, so this shows how important scenario. Okay, so let me clear up this and let me break up the definition of data science into the terms that I had just shared. So interdisciplinary fields, the principles or the fundamentals or the techniques have been borrowed from multiple disciplines like statistics, mathematics, physics, computer science, biology, blah blah blah. So I'm not sharing this definition to discourage somebody or to tell you how difficult it is. I'm just giving you a picture as to what is the expectation when you are starting your career or when you're moving ahead in your career in data science. So it takes the rules, traits, and properties from these disciplines and combines them to build machine learning solutions for the problems at hand. The data can be of various forms. You can have data from sensors. Okay, a quick example of a sensor data can be the energy meter data, which has been the energy meter sensors which have been deployed in the US, I think in the state of California. So they're sending back data to the energy provider corporation to understand the breakup of what appliances or what times of the day or what times of the year the energy consumption spikes or comes down. so that they can better handle the energy load distribution and they can better tackle the energy crisis if it happens. Okay. Similarly, you can have sensors deployed on the rail tracks to understand if if there is any crack on the rail track, if there is any accident, there is possibility of an accident because of the rail crack, or the rails which are running, if there are any head-on collision probability, a lot of things. And this is all happening now because I've worked on a couple of projects, and this is all happening right now. So it's not something that it's it's uh, it's something that we are talking about of the future, but it's all happening right now. Okay. So you can also have clickstream data. Okay. So Kumar has a question for, he wants to understand. Okay. So he's interested in learning data science and he's trying to understand. Okay, he's a SQL DBA. So I understand. So the question most of you might have, I'm say a Java programmer, I'm say a C programmer, I am a SQL DBA, I am a SAS programmer. What is in it for me and what do you want from me so that I'm to the level or the caliber of a data scientist? So this is precisely what I'll answer today. Okay, what is expected from you? And the tool or the approach that will help me define this is Python. Okay, so you at the end of the session you will understand what is expected from you when you're saying I'm trying to become a data scientist, or I'm on my path to become a data scientist, and you will be able to map your progress to your goals, because whatever I'll share is all what is expected from you. So if you want to become a data scientist, that is your goal. What is your progress? Are you moving in that direction? Okay, so in the coming session, I'll tell you how it works out. And let us first understand this field first. This field's definition is very vague. It's commonly misunderstood. So let us understand what all is encapsulated in this field. So you can have transaction data. Banks have a lot of transaction data, the card swipes that is happening, the purchases and the sales that are happening. They want to understand the consumer behavior from the transaction data. Now this statement is very simple. I want to understand the consumer behavior from the card transaction data. But to do that, there is an entire application pipeline which is set up from data capture to model deployment to understand how a consumer X is behaving. Okay, so it may sound simple, but to implement that you have to deploy a complete data pipeline, and I'll show you how it works. Okay, you can also have weather data. Weather data is very useful in a lot of applications. If you're running an airline, weather data becomes the god data for you. If you have weather data, you can plan your flights, you can plan your landings, you can plan the fuel you want to pump in the aircraft, and a lot of other things. Even real-time updates can be pushed to the travelers. Okay, so weather data is very critical. Now this data is coming from varied sources. That is why we are calling it various forms. This is coming from varied sources, and they can also be structured or unstructured. Now this term is also commonly misunderstood. Structured means you are able to store that data in a RDBMS, in a relational database management system. Okay, you have some logic of defining that your data consists of this row and this column. If you don't have that, your data is unstructured, because ultimately more than 95% of the processing that is happening in today's production systems is working on the structured data. You have data in the tables, right? And you fire your queries against the tables, you prepare your reports against the tables, you capture the data and store them in tables, the RDBMS. Okay, now the ecosystem of today's generation or today's scenario has given birth to unstructured data as well. Now the most common example is the social media data. You have comments from Twitter, you have comments from Facebook, you have images on Facebook, you have videos posted on Facebook as well as Twitter. You have a lot of data which is very difficult to be categorized into rows and columns. Think about it. If you have a Facebook post and you want to store it in a database, I mean, how will you define the length of that column which is storing that comment? Somebody might have written, somebody like me will only write one line, so and so, and that's it. Somebody loves to write long posts. How are you going to define that column? How are you going to capture it? How are you going to structure it? All these issues come up when you are talking about the social media data, or suppose somebody is chatting with a customer sales representative. How will he understand that this chat data, what I have, whether the customer at the end of the session was happy with that chat or was disappointed or was neutral, what was his sentiment? So that's what we call the sentiment analysis. How will you understand that? So in order to tackle those questions, you first have to bring in the data into your application, into your tool, which might be R, SAS, Python, anything. But you have to bring that data first. And in order to bring that data, you have to store that data first. Okay. So Manoj, you have a very valid question of how is Python different from R and which is better. I'll cover it in the next slide. This is a very relevant question. In fact, when I was trying to take a call as to which application should I pick around 5-7 years back, I faced the same question because I'm a hardcore SAS programmer. Okay, I started my career in SAS, picked up Python in between, and then I had to take a call whether I should delve into R or stick with Python. So I'll answer all those questions, and these are all very relevant questions for anybody into today's scenario. Okay, so statistics, machine learning, data mining, predictive analytics, all these play a role when you're talking about data science, right? One over the other. So data science involves getting involved in all the activities that range from data pull to presenting the results in the form of visualization and deploying those models in production. Your job is not done until the time somebody starts using your models or machine learning models or statistical models and derives some benefit, some profit, some dollars out of it, or is able to solve the problem he was trying to solve, right? So if I stack together what needs to be done in a data science process, this is what the flow chart will look like, and this is a very iterative process. You will never become a champion data scientist that you will build one model using one approach and you will say this is it, this is the best model that can be built on this data. No, it's not. It never happens because a lot of factors are there which determine the success of your model or the success rate of your final model that you have deployed. So you have to take into account a lot of factors. You have to at least iterate 3 to 4 times to come to a model which says, okay, this is the final model that I'm going to deploy for this particular problem at hand. So if I talk about the steps, the first step is you will ask an interesting question. Now, interesting is a very subjective word. Something might be interesting for somebody and something might not be that interesting for somebody else. But the point is, in a domain, there are topics or there are questions of interest. For example, in agriculture, the farmer is always interested in knowing how will the monsoons be this year, or what will be the weather like in December, or what will be the weather like in January. For a finance organization, they'll always be interested in how to boost their credit card activations, or say they ran a campaign and they want to make sure they only target the people who are most likely to get their credit cards activated. So all these are relevant and interesting questions pertaining to different domains. Okay, what is the goal you're trying to meet? Okay, what would you do if you had all the data? What would you want to predict or estimate? Always your problem starts with, or your data science process starts with framing the problem or asking the right question. And this is very critical, and many people I've seen, they make mistakes in this. They frame a very general question. They don't precisely tackle the problem by framing the right question. If you frame the general and wrong question, you will never be able to come up with an answer which satisfies the end user or which even satisfies your own purpose. You will not only be able to justify what you have built, right? So ask the right question, focused, precise, and which pertains to the immediate problem at hand. For example, I talked about a financial organization. So the immediate question that they have at hand is how to identify the users to which I will promote or offer my credit card so that they have a very high probability. And when I say very high probability, it means greater than 50%, right? Greater than 50%. At least if it is less than 50%, they have a higher probability of not activating the or buying the credit card. So they have a higher probability of activating the credit card. Okay. Now, once you have framed your hypothesis or your question, this is also called framing the hypothesis. So you get the data for that question. you pull the data from whatever sources you have. Now in the production systems, the banks have the transactions databases, the customer relationship database, and a lot of other databases. They use that database to pull up relevant data for the customer and try to understand by exploring the data if there are any anomalies in the data. If there are any anomalies, you have to fix it. Any missing values, any outlier values. Now all these are statistical terms, but you have to have a decent understanding of statistics to be a champion data scientist. If you don't have a good exposure to statistics, and the many people feel this is a showstopper, this is a roadblock, but I'm telling you, even I had to go through a little bit of statistics first to understand what the predictive modeling models are doing and what the machine learning algorithms are doing. So Harinder has a question with where data scientist and big data analysis cross each other. So big data analytics is something that when a data scales up, when your problem at hand has the data which cannot be traditionally modeled using traditional RDBMS, your problem becomes a big data problem. For example, let's talk about sensors data. If your energy meter is emitting a data from the sensor, say every minute or every hour, imagine the number of meters which are deployed in the entire California state, and imagine the amount of data that is being pumped to the energy station, and they have to store it, and they have to process it, and they have to analyze it. So the overlap is definitely there. There's a good question. The overlap is definitely there, but the use case of big data only comes in the picture when you really have big data. If your problem can be modeled or solved using traditional approach, okay, traditional approach means running it on a server or using your commodity hardware, using standard tools like R, Python, and SAS. You don't need something like GraphLab Create or something like Spark, something like Hadoop. Then you're good. You can work on your own commodity hardware or server. But if your data grows and becomes huge, the problem starts even in storing the data. Forget about analyzing the data. The problem starts even in storing the data. So in order to store and analyze the data, you have to take a call whether your problem or the data that you're collecting will scale up to this extent or not. If you have a possibility, if there is a possibility that it will scale up to this extent, you should always be prepared to use the Hadoop or Spark infrastructure in the first place. Okay, so Manoj says, what is the difference between data mining and machine learning? These are all very overlapping terminologies, and I would really request all of you not to get confused with these terminologies, because at the end of the day, you will be building models. Always, you will be building models, and whatever prerequisites are there to build the models, you will have to perform all those responsibilities. Are you getting this point? The responsibilities remain the same almost in all these different key terms that we are talking about now: machine learning, predictive modeling, data mining, data scientist. So these are specific terms because of the schools from where they came from. Machine learning came from a specifically computer programming school. The statistics and all was incorporated later on, but it started with theoretical computer science, and predictive modeling came directly from statistics. So whichever domain started growing and people started contributing to that domain, so that particular domain grew, and they gave a name to that particular school of thought. So machine learning is a school of thought, data mining is a school of thought, predictive modeling is a school of thought. Okay, but at the end of the day, all of you are building models, and in doing so, following these steps in an iterative manner. So you'll explore the data, you'll model that data, and then you will build a clear-cut visualization which communicates the story to the end user, because the end user is not a statistician or a data scientist. He is a businessman. He knows his business, but he doesn't understand the machine learning terms, the data scientist terms. So it is your responsibility to translate the results from your model into a language that the business user understands. Okay, so this is all the responsibility of the data scientist, and then of course you will deploy the model. So problem formulation is there. You capture the data, you model the data, and then you deploy it. So this is an iterative approach. Okay, you have to iterate at least twice or thrice to come to a model which you feel would work on the data which is still unseen by the model. At the end of the day, your model will run on the data which it has still not seen, okay, on which it was not built, on which it was not trained. So it is the test data which determines how efficient, how accurate, how good, how robust your model is. If it doesn't work, no matter what statistics or what mathematics you put into that model, that is a piece of garbage. You will have to discard that model, build a model again. That is how it works. This is iterative, and I have done it myself. I have discarded models on which I spent 7-10 days working hard on it, and I had to discard it because it didn't work well on the test data. However, you have to backtrack and understand why it didn't work on the in this figure. There are data sources. You have to build a pipeline, you have to understand the data format, you have to do some analytics. So ingest the data, explore and visualize the data, generate and select features. We'll talk about them a little bit later. You have to train your machine learning models. If everything is fine, the test performance is good, you deploy and consume the model in product. Always at the end of the day, your model will be deployed in production and you will get the results from the model which user will use, right? This is the objective of the model. And the source again starts, you have a planning, you have a meeting of your business stakeholders, and then they prepare some business problems. I mean, they have some business problems at hand, and again the same cycle. Okay, I think the previous slide, typical data science. Okay, so somebody is asking if we are talking about iterative approach, what do you mean by this? So iterative approach means something like agile methodology. If you have been through this term, it means you will do these steps in a rapid fashion and try to come up with the results at the end of the iteration. First of all, can you hear me? Are there any audio issues? Arti, can you hear me now? Okay. So you are asking for the previous slide. So let me, this one, the eightfold path of data science. Okay, let me quickly see if the audio can be fixed from my end. Okay. Okay. So this slide, is it making sense to everyone? The iteration means you will follow these 4 steps multiple times. You will complete one cycle of phase 1, phase 2, phase 3, phase 4, and then see the results, discuss the results with your stakeholders, come back, follow these steps again till the time your model is robust enough and you are able to come up with a model which is acceptable to the stakeholders, as well as you can justify the results of that model. Don't worry, you are slide, because what we'll be walking through is you will come back to it once again. So Chandrakala, is this the slide you want to look at? Okay, so this is typical data science life cycle. right? So life cycle means how does it start and how does it end? It starts with data ingestion. It first starts with formulating a business problem, and then data ingestion, processing it, uh, working working out the models, or deploying, or developing the models on top of that data, and finally deploying those models in production. Okay. Okay. uh, share the difference between machine learning and statistical modeling and data science also, because I know many of you might be having these questions. There are so many terms. See, the thumb rule is there are lots of technical jargons in data science, machine learning, and statistical modeling. The right approach is stick to one term, stick to one terminology which you are following, and go in depth in that. Follow it closely, figure out everything that is around it, understand it. If you're unable to understand it, ask the questions on forums. I'll tell you what forums are there, or take a course wherein you have an instructor who is teaching you this. Because what happens is, when you have a course where somebody is teaching you, you'll be able to clarify all these doubts on a one-on-one session. Okay, so machine learning is an algorithm that can learn from data without relying on rules-based programming. It is a subfield of computer science. Okay, and artificial intelligence, which is dealing with building system that can learn from the data instead of you as a programmer programming it explicitly. Okay, so, and statistical modeling is a bit more traditional and conventional thing. It is a formalization of relationships between variables in the form of mathematical equations. It is a subfield of maths which deals with finding relationships between variables to predict an outcome. Now, data science encapsulates the best of everything and tries to find solutions to complex problems which are there in today's scenario using well-tested machine learning algorithms like classification, random forest, deep learning, and many more. We we have now understood what data science comprises of. Now, we quickly need to understand who is a data scientist and what are the responsibilities. So data scientist is somebody who knows more statistics than a software programmer and knows more software programming than a statistician. This is a very overly simplified definition which is given by Josh. Josh is a data scientist at Cloudera, and he's a great programmer. So the idea is you should know statistics which is relevant to your machine learning or statistical modeling domain, right? See, statistics is very vast. If you start diving into statistics, you can do a PhD in statistics. That is not the idea. That is not the point. You need to understand the fundamentals of statistics which are relevant to machine learning and data science. And you need to be a good programmer. You need to know your logic. You need to be able to translate your logic in your brain to a computer program. If you can do that, you are on the track to become a data scientist. Frame a machine learning problem from a business problem, you must know how to pull the data and do data wrangling. Data wrangling means cleaning the data, mapping the data into a format so that you can store it, and doing all sort of pre-processing on the data. Okay, and apart from having good theoretical knowledge on statistics, maths, and other subfields, he should also be well versed in statistical tools and applications like R, SAS, and Python. Any of these or all of these. Okay, and last but not the least, he must be good in visualization too. So because the end user will never understand what the model has done. So you have to build a storyline and you have to showcase what you have done and what is the result or the bottom line that model is conveying. So this is, if the data scientist is unable to fulfill all these roles, at least he should be able to get his team working on all these aspects of development. Okay, so now to the $1 million question, that if you are given a choice of picking data science, what will you pick? So R, SAS or Python? And I'll share this perspective from my own experience. And I started my career with SAS, and initially it was just SAS programming, and quickly it turned out into hardcore statistical programming in SAS, okay, predictive modeling. Now, if you are a fresher, if you're a clean slate, what I would recommend is start with R. R is focused on statistical programming, okay? So you will start from a clean slate, you will understand the statistical concepts first, and then you will pick up the logic which is given in R. So R is very intuitive in the sense that when it takes the perspective of the programmer and works and they have built up the packages or the functions accordingly. Not very tough to learn. The community is very strong. Our community is growing by minutes, by seconds, not by hours or days. It's growing by minutes, by seconds. So it's a very fast evolving community. Your questions will be answered in no time, and it's all open source. It's all free. It's all up to you. What do you want to do with it? But if you have some exposure on SAS or Python, go ahead, stick to it, and focus on it. Just don't learn a language or a tool because you think there are more job opportunities in it. No, that's not how it works. That's not how it works, and that will never help you. Okay, you need to understand why you want to learn this. Okay, what is your objective? If you are already there in predictive modeling or statistical modeling, you want to build more on it. Whatever tool you're using, if it suffices, if it is one of these three, you can go ahead with that. All three are powerful tools. Okay, all three are powerful tools. You can pick any of these. But if you are starting afresh, you have no idea about what it is, start with R, and R will help you in understanding the statistical concepts as well as the way to implement those concepts in R language in itself. Okay, R has a more dated background than Python, and SAS has the most dated background. Oldest player in this field is SAS. So people want to know the communities where they can post the queries. I'll let you know everything. Okay, in fact I believe the presentation also we can share, or the recording will be shared, so you will get the links and everything where you can post your queries. And of course there is Stack Overflow, right? Stack Overflow is the holy bible of everything. So you have dedicated communities of R, Python and SAS and Stack Overflow as well, so you can always go to Stack Overflow and post your queries. And it's a call that you have to take, keeping your experience in mind, keeping your capabilities in mind. If you don't know statistics, okay, and you're trying to master R, SAS or Python, that's not advisable. First go through statistics, first go through basic maths concepts, and then only start picking up any of these. Otherwise, the way these algorithms or these tests or these statistical concepts are implemented in any of these applications, you won't be able to understand or appreciate what is happening. Now, prevent yourself and avoid deep diving into these applications to the level of deep learning, random forest, neural network, perceptron training. These are all pretty advanced machine learning techniques. You are still a novice. I would recommend don't try out these techniques straight away. Yeah, R is a language, and R is which is a scripting language which has been developed by the community of college students and professors. So the point is, start from the beginning, spend some time mastering those concepts, and some time means it might be a matter of months. So it's not that quick. The learning curve is definitely steep in the beginning, but master those concepts first and then get started running those algorithms by feeding your own data, interpreting the results, going back, changing the algorithm, running again the model, checking the results, validating the results, and so on. This is what we call iteration. This is what is called iteration. Okay, so I hope now most of you would have understood what would be the right application for you to start with. So R is a language, is an application which is free, open source. Python is a language, is an application which is free and open source. SAS is a proprietary product, or rather I should say was a proprietary product, but given the tough competition it has got from R and Python, they have released a virtual machine on their website, which is freely downloadable and which is as good as any SaaS interface, like SaaS Enterprise Guide, SaaS DI, or whatever. So it is called the SaaS Studio on a SaaS University Edition. So what they have projected is they want the students to get engaged in the SaaS community. So they have given a SaaS Studio on a SaaS University Edition, which you can download and you can play it in a VMware player or Oracle VirtualBox, and it is a great interface to work in SaaS. This is a great initiative that SaaS people have taken to counter the growth of R and Python, because nowadays almost all the machine learning and statistical modeling is being switched over to R and Python, except the one which was already there in SAS. So with this, we now come to the logical point to understand what is Python. Okay, so Python is an interpreted, object-oriented, high-level programming language. It has high-level built-in data structures like dictionaries, lists, combined with dynamic typing and dynamic binding, and make it very attractive for rapid development, as well as for using as a scripting or glue language to connect the existing components together. Now, Python has been there for long, but when we talk about Python for data science, it's relatively new than R. Okay, R has a higher age than Python when we are talking about statistical modeling, but Python is catching up very fast because the community, the Python community is very strong and is very evolving, even at almost matching the pace of what our community is doing. So it's almost like a neck to neck race between R and Python for the machine learning or the data science domain. So the advantage that Python has is the syntax, the program, the approach, the modules, everything is very easy to interpret, read, interpret, and execute. It's unlike SAS. SAS is a completely different game altogether. Okay, Python is very simple to read and understand. If I'll show you the Python code that we'll run, and you will be surprised to see that just few lines of code are pulling up data from websites. Single statement is pulling up data from website. Single statement is storing it in a data frame. So when you have such simple implementation, now what kind of implementation is this? This is a high level implementation. Python is a high level programming language, right? The disadvantage of such a programming language is higher execution times, but the advantage is more productivity from the programmer's end. The programmer easily understands what he needs to do and he gets it done very quickly. It's another game that the program might take some time to run, because the higher level conversion will be there to the machine language and it will take some time. Never mind, but from a programmer's perspective, it opens up a plethora of modules and libraries uh, to work in data science. So it's incredibly easy to read and understand. It is very fast to develop applications in Python. So it is said, it's a very random thought, but it is said that the Python developer can accomplish in 2 months what a C++ developer might take more than 10 months. And the reason behind it is simple. It's a high level language, more high level implementations are there. You can quickly code your program rather than a C++ developer who had to declare the object, declare the class, write down the whole code, call the code within the code, and then build a whole project out of it. So that is where the difference comes up. So the execution time is a con, but people are trying with Python 3.x. There might be some efficiencies that are coming up, and above all, it's free. So Manoj, you have a question. Is it necessary to learn base SAS? I mean, if you are trying to build a career in SAS, yes, of course. Of course, you have to start with base SAS, and base SAS is a very is the bedrock of SAS. Base SAS has so many concepts which are definitely required so that you move to a level wherein you start implementing machine learning algorithms in SAS. So Jyotsna, the ID that you can use is PyCharm, but PyCharm is a slightly heavyweight ID. I'll give you a walkthrough of Jupyter Notebook. Okay, it's called JUPYTER. Yeah, you can use PyDev or see, there are lots of uh, IDs available for Python, lots and lots. Again, I'll recommend stick to one and get yourself comfortable in that ID. So what I'll walk you through is Jupyter Notebook. I'll tell you the advantages of that, and I'll tell you how it works. So the IDE is used in production environments wherein you are building a Python application and you are deploying it in some production system. The way you are learning and you are progressing on the path of machine learning. The application that will suit best for you is Jupyter Notebook, and I'll give you a walkthrough of it today. That is the reason I've deliberately picked up Jupyter Notebook to let you know how to work in Jupyter Notebook and how to get your programs up and running in it. Okay, so if you're talking about Python, what do you have? I mean, if there are people with varied experiences, varied skill sets. So what does Python have for all of them? So Python has many modules or packages available which suit almost every need of a developer. To cite a few models or the which serve the purpose. For web developers, you have something called a Django framework. For data scientists, you have something called a NumPy, SciPy, Pandas, and scikit-learn modules. For text mining, you have ntlk module available, which is the natural language toolkit. For image processing, you have scikit-image, and there is a possibility that if you have a problem at hand, say geographical information system GIS, or say traffic mapping or whatever, you might have a module in Python which will help you write your codes on a high level and get your job done. Are you getting it? This is the advantage of a high level programming language. It will have some implementation of some requirement at a high level, and you can use that implementation in your code to get to fulfill your objective. Now, this ecosystem is extremely favorable to either leverage the existing modules, okay, or collaborate and build a new one. Either you will have something that you can quickly reuse in your code and you can get your job done, or you can collaborate with folks, build a new one and release to the public and become a hero of open source community. Of course, if you do it, your name is printed on the books, whichever books are released for that module or whatever. So for Pandas we have Wes McKinney. For scikit-learn also we have people. So if you are so much interested and you really want your problem to be solved, not by some proprietary software like SAS or some other SPSS or some other software, you can build your own modules. They will be vetted thoroughly by the Python community. There are moderators, they will vet that module, and once all the test cases are passed and everything is good, they will be released to the public for download and use in their own application. How do you get hold of Python? So Python is open source. You can download it from the link that comes up on your screen. This will be shared, so you can copy this link and you can go to that URL and download it. You can set up your own ID as somebody just asked, so I advise PyCharm. So the point is you should have a Python kernel running, and on top of it you can have IDs which can leverage that kernel. It is exactly similar to R. I mean, R copied this approach. So let us say that R and Python are siblings in this aspect. You have a kernel, okay? You have a kernel which is downloaded from the python.org website. You install it and then you install your IDE, PyCharm, PyDev, whatever, okay, Anaconda, whatever it is. You install that and then your ID will recognize the kernel, and then you can write your codes and submit your codes on the ID. Are you getting it? So this is a local implementation that we are talking about. If you have a server somewhere which is running the Python kernel, you will submit your codes to the server. So for people who want to get a flavor of and get started quickly by writing their own codes and running the codes and seeing the output and doing iterative processing, I would recommend the Anaconda setup from the Continuum Analytics webpage. Okay, it's continuum.io. Simple, continuum.io. They have compiled the most essential setups for the entire Python development, in the Python application, in the Python environment. So they have the Python kernel, which is the latest release 3.5. They have the Spider ID. They have the Jupyter notebook. They have the IPython notebook. They have the simple idle shell, everything. So if you download the continuum analytics anaconda setup, you have everything in one place. You don't have to worry about anything else, right? It's not that you have to install the kernel first and then install the id and then start working. No, install the anaconda setup and you're good with starting your development on Python 3.5. As of now, they are giving 3.5. I think they have also shared 2.4, but I would strongly recommend not using 2.x versions because mostly the codes are getting ported to 3.5 and the future belongs to 3.5. It's already there in production in some environments, and if it is not, people are porting their codes to 3.5. So don't go with the 2.x version, rather start with the 3.5 installed on your machine, and you simply open up your command prompt, okay, and say Python. This is what it should look like. So I have a 64-bit machine, so it's showing the hardware of that machine and it's showing Python 3.5.2. This is how it should look like on your machine as well. The Python version should be correct, and depending upon the hardware architecture that you have on your laptops or desktops, you will see a 32-bit or a 64-bit anaconda setup, and you should download that particular setup from the Continuum website. If you have a 32-bit machine, download the 32-bit setup, right? So somebody is asking for R. For R, you use RStudio. RStudio is a champion IDE for R. Very uh, lightweight and very nice. In fact, I'm a big fan of RStudio. So you can use RStudio, and RStudio is so smart that you have multiple R kernels installed on your machine. It will automatically pick up the latest one. You don't have to worry about it. The package installation, the graph libraries, the plotting, the even the shiny applications, everything can be done on RStudio. It's a very nice ID. Okay. So once you have, so RStudio, are you talking about the RStudio version? So you can go into the RStudio website. I'm not sure what version they are having right now. Uh, Rather, you should be worried about the R version, right? So R is, I think, 3.3.2 is there now. So don't worry about the RStudio version. Whatever is there on the website, it's the latest one. It will work. Rather, you should be focused on what kernel of R is released now. What stable kernel of R is released now. So I think it is 3.3 point something. So get that kernel installed, then install RStudio, and RStudio will automatically pick that R kernel, and you can start development in RStudio. Okay, so you will be able to see all these options under your Anaconda folder. You'll see Anaconda Cloud, which is the cloud implementation of Python for which the Continuum folks have done. That means you can submit your code there, store your data there. I mean, this is the cloud implementation, right? So if you don't want to do something locally, you can use their cloud, which is both a free and paid version. You have a navigator, you have the Anaconda prompt, which is the Python prompt, IPython, Jupyter notebook. This is where the essence is. This is what we'll use, the Jupyter notebook, and this is the Spider ID. Okay. And these screenshots one by one because mostly people get stuck here. So Anil, you want to know, you use Web2Py for developing simple application in Python, and which is better instead of Web2Py? See, I have worked on PyCharm and I find it very useful. So I would recommend, I have never used Web2Py. So I've used PyCharm ID, and PyCharm is intuitive in a lot of ways. I mean, it's helpful. No, I haven't heard about Iron Python. I don't know what is it. So see, many IDs are available. Pick one, stick to it. Okay. Don't worry whether some IDs have some features, some IDs don't have. Anyways, you want to get your job done. So if you find a roundabout way to do something in an ID, you should know that, right? Because pick one ID and stick to it. It's something like Eclipse. Eclipse, you should know how to work your way in Eclipse, right? So pick one ID. I would recommend PyCharm. I would recommend Jupyter Notebook. If you have worked on some other ID, keep using that. It's not a problem. None of the IDs is so bad that you should drop it altogether. If you haven't used one, pick one of these two. Okay, so if everything is installed properly, and the reason I'm walking you through the installation steps so in such a detail is because this is what will get you started. Most of the people don't get started properly when they are trying to develop their machine learning codes, and they're trying to understand the implementations. So if you don't have these all these set up properly, you'll never be able to get started even. So today I want all of you to at least get started and write your code and see the output and understand the implementation. Okay, so Jupyter notebook can be pulled up in this fashion. If the Jupyter notebook is properly installed, it should also show you the interface and everything, which I'll just show you. But before that, quickly, just a quick word, quick thought. Use Python 3.x kernel, not 2.x, because we are porting to 3.x. So it to 3.x, and there will be considerable changes, significant changes. So it will be a kind of rewriting the entire code. Although there are codes available which can convert 2.x to a 3.x directly, but the code breaks also because the integer division and all has changed in 3.x. So you will not understand why the errors or why the issues are coming up. So I will, if you click on the Jupyter notebook icon which I just shown you, the browser home, right. I'll give it a second. I want everyone to see this. Yeah, sorry. So I know there is a bit of lag, so don't worry. I'll go a bit slow. I want everyone to have a look at the Jupyter Notebooks homepage. Okay, this is what the Jupyter Notebook homepage looks like, and it has a lot of features, lot of properties. I'll touch upon this. This is a Windows machine. So in the Windows machine where it is looking at, if you have a Mac or some other laptop, you will see some others here. And what you can do from here is you can open up notebooks, and it also has text files and folders options. Okay, but what we'll talk about today is open up notebooks. So if you click on Python default, and there are two, so don't worry about these two. It has more related to the kernel, so don't worry about this. You can use Python default always. Python default. Okay, right now we call it a notebook because what do you do in a notebook? You keep on writing and it is saved, right? This is what a notebook is in a real life. You keep on writing in the notebook, and the stuff that you're writing is saved there. It doesn't go out unless you're writing with a magical ink, right? So the code that you're writing in this notebook will be saved from by the logic of save and checkpoint, this option. And errors, that means if there is any, this is interactive, so whatever input you are giving, it will give you the output as well, right? Interactive IPython, the IPython logic is also there. So you give it, so the input comes as in and the output comes out as out. So the IPython logic is also there. Okay, the issue was there. It will give you a stack Okay. Now, this is a big heading comment. This is a small heading comment, and even smaller, and various other comments can be introduced. The point is, along with the codes, you can put in your own comments, and you create a notebook which is a workflow of start to end. What did you do? How did you do? What was the output? And in the end, what did you get? Is it making sense to everyone? Okay. So there are commands. If you have a Jupyter notebook in front of you, go ahead, run those commands. If you don't have, we'll definitely share this recording and you can try it out at home. So if I do ls in the Linux world or the Unix world means listing of the files. So the command in notebook works similarly in the same fashion, or the Python commands or the Python statements work exactly in the same fashion like they would have worked on the Python shell. Now understand this. If I open up a Python shell, okay, if I open up a Python shell and whatever statements were submitted on that Python shell, okay, they will work exactly in the same fashion if you submit them on the Jupyter notebook right here. Jupyter notebook like ls and but most statements or the Python specific codes will all work perfectly fine, because that is what this notebook intends to do. So I'm going to import. I'll now walk you through a little bit of coding. You get comfortable in importing modules to the notebook and you start developing your codes on it. Okay. So open up, if you open up a new notebook, that means you've opened up a new Jupyter notebook which you can save. You can either shut down the this notebook will keep running till the time the user shuts down. Okay. So, into the Python system. Now, where are we trying to import it? Into our Jupyter notebook or our Python kernel, right? So either we will import from a data science perspective, either we'll import it into a NumPy array or we'll import it as a data frame in pandas. These two are different things, but depending upon your use case, either you will import it in a data array, in a NumPy array, or a data frame in pandas. Okay. Okay. So before diving into the NumPy array, let's understand. Okay. So Chandrakala, you have a question. NumPy and pandas? No, these are modules. NumPy and pandas are modules or packages available in Python for data science. Okay. And why do we have a module altogether? You will understand, because the optimization or the objectives that have to be met in data science need special data structures to hold the data. That is why NumPy and pandas are there. Okay. Yeah, Jyotsna, I'll give you a live example of running codes in Jupyter Notebook. Don't worry. So let's first understand, when I saying NumPy arrays, what does it mean? So NumPy array is a data structure that stores the values of same data type, numerical data type. right? So in Python, this is the main difference between arrays and lists. While Python list can contain values corresponding to different data types, the arrays in Python can only contain values corresponding to the same data type. Primary difference. And the NumPy arrays are optimized for matrix operations. They are optimized for matrix algebraic operations. Okay. So NumPy are the Python standard to store the numerical data in Python. They are efficient, fast, and clean. NumPy arrays are often essential for other packages like scit-learn. Now, scit-learn is the main machine learning package in Python. Okay, this is the package, or this is the module that is used to implement or to execute the machine learning algorithms on the data which you have, right? So NumPy itself has a number of inbuilt functions that make it easier and more efficient for us to import data as arrays into the NumPy functions. So you have load text function, you have generate from text function. You can use these functions into the Python system. So we'll see a data set and we'll try to import it. And the data set that I'm using is MNIST data. I'm not sure if you have if you have read this or seen this data set earlier, but this is the Mixed National Institute of Standards and Technology database. The objective of this database is in the US, 500 unique people were asked to write out the digits from 0 to 9. Okay, and this entire database corresponds to handwriting recognition. Now 500 folks wrote digits from 0 to 9, and what was done was the images of those digits were captured and they were standardized, centralized, and some pre-processing was done so that how the number say 8 is written by 500 different people could be seen in one chart, right? See, this is how machine learning works. It trains the model on some training data, and when the training is done, when the robustness and the accuracy is reached, then the model is exposed to the test data. And in test data, the model has to guess or evaluate or estimate what will be the response basis the input variables. So suppose, and everybody writes the numbers differently. So the idea was to train the model on all the 10 numbers 0 to 9, and then capture the pixel intensities of those numbers into images. And in order to, now image is something that you cannot quickly process in Python or any language. It will require a lot of complicated processing. So the pixel intensity was captured, and then an array was created of 28 by 28 pixel after normalization. Okay, so if you have a 28 by 28 array, how many elements will be there in that array? 784. Are you getting this? First row, first column, second row, second column, third row, third column, so on. First row, 28th column, and similarly 28th row, 28th column. So if you count them one by one, the number of elements in that array will be 784. So the data set that you will have at hand is the first. Focus on this screenshot of the Excel that I put up. The first column will be your variable, or your label, or your number that you are trying to model, and all the rest of the columns contain the pixel intensity in that particular row column of the matrix. So du, so this is du, otherwise the first element that will come up will be first row, first column, second will be first row, second column, and so on up till 784 columns. It's a big file. So intensity means if the number 0 comes up, it means it was white, it was all background, there was no number written there. And if it is 255, it means there was something written in that pixel, completely black. Anything in between means either an edge or half black, half white, whatever it is. So the pixel intensity was captured. Okay. Now, if I show you in the cell might have a green border or a blue border. If the cell has a green border, it means it is waiting for your input. You can go ahead, write your statement or code and submit it. How do you submit it? Press shift, hit enter. Okay. What have we done? We have imported the module numpy. Now I hope if you have done a little bit of programming in Python or R or any other such scripting language wherein memory optimization is a top concern. Not all the libraries or modules are loaded at runtime at the start of a application. Even in R, you import or you load only those modules or packages or libraries which you require to be used in this particular application or in this particular coding instance. If you want to use numpy functions and numpy methods, you will import numpy as and give an alias as np and you will hit enter. Now numpy is available for processing or for using the functions which belong to numpy in your current Jupyter notebook instance. Okay. Now I am trying to import the file name. It's again very simple. Define a variable called file name. Give the entire path on your local machine. See how simple and intuitive this is. This cannot be a simpler task to import a data set. I'm telling you, this is the simplest way to import. Again, shift enter. Okay. That means this file name is now stored in the variable called file name, and then load text. It has come from the numpy. This is a function in the numpy. So numpy np alias is defined dot load text file name, and then what is the delimiter of that file? A comma. Go ahead and submit this as well. Now you can see a star coming up here. This means it is still processing. Although the control has come up to the next cell, okay, but it is still processing. And if you see where am I pointing to on the screen, you will see it says kernel busy. Can everybody see this? Kernel busy means it's still processing. It's a big file. It will process. It will take some time. Okay. One records, and each record has how many columns? 785 columns. 784 columns captured from the 28 cross 28 array, and one column which contains the actual label or the actual digit which was modeled using those 784 columns. Any questions on this data set? Okay, the import is done. You see the star is so and to see how the data looks like, you can say this is how you'll print out the array in Python, right? Now I'm not going into the depths of how to print out the array or how what exactly is the architecture of array, how do you do these array operations, because that's something that belongs to the core Python language, and we are focused more geared more towards understanding the data science part in Python. Okay, so this is how the array looks like. These are the labels and these are the pixel intensities. All this is here. Simple, right? Okay, let us use another file to import, and let us see if the load text function of the numpy works fine with all the types of flat files that we are using, all the comma separated files. I have used another file, the Titanic file, which you can download from either Kaggle datasets or GitHub. It is available in both the URLs. So what is the Titanic file? The Titanic file contains the details of the passengers which were present on the Titanic ship and what was their fate. Did they survive or did they not survive, and everything about it. So this is what the age, sibling, table embark. So all these things are array which contained only numbers, and the label or the variable which contain the actual digit. Titanic file has both numbers and characters, right? This is a string, this is a number. So let me define the variable file Titanic and let me run this. It is the numpy array that is storing that data. Numpy have same type of data for all the elements of the array, and which is numerical. Now here we use the pandas module. Okay, we use the pandas module. This is where pandas is. So we'll say import pandas as PD. Okay, and then we define the variable data Titanic, and we simply say pd dot read csv file Titanic, and so it has read the Titanic file and stored it in an object called data Titanic. You might know the head and tail function which we use frequently in Unix and Linux. It also works here in Python. So if I say data Titanic dot head, it will show me what it is now. If I say type of this, pandas core frame dot data frame. It is no more a numpy array. It is a data frame. Clear? With the R data frames, okay. I'm giving you comparisons between R, SAS and Python so that you are able to understand if there are any similarities or if there are any differences across applications in terms of what objective you want to achieve. Right now, here my objective was to bring in the data into my Python application, into my Python platform. I used NumPy to import the numerical data, but when the mixed data was being imported, the function broke down. So we'll use pandas, and pandas helps import the file into a data frame, which is a row and column combination of your data into your Python system. So if you compare it with our data frames, it is exactly the same. It is exactly the same as our data frames. Okay, and what you call as data set in SAS. Why do we have different things in different platforms? Because the way all these are implemented across platforms is different. The way functions, modules and other statements are processed in SAS is different than in Python. So if Python has to create a data frame, it will use some other function or some other method, some other technique to build that data frame internally. Externally, it will look like the same. Everything will look like the same. The data set, the data frame in R, the data frame in Python, everything will look exactly the same. But internally, it will be different. Right? And why did data frame come into the picture? Because what does a data scientist need? He needs a two-dimensional labeled data structure. He needs columns of potentially different data types. Okay. He can manipulate, slice, reshape, group by, join, merge, do anything on that data set. He can perform statistical operations on it, and he can work with time series data. So there are a lot of expectations. There are a lot of functions which data scientist has to work on the data set or the data which is imported into the application. So if it doesn't fulfill the robustness of a data structure, most of these operations will break. And that is where Wes McKinney developed the pandas module for Python. So Python has been so if I tell you in terms of Wes McKinney himself, he says Python has long been great for data munging and preparation. Data munging, again, cleaning of data, data processing, but less so for data analysis and modeling. And this is very true. I'm telling you, before pandas, it was a nightmare to build any machine learning model in Python, as true as this. Okay, and the reason is simple. If you have to open a file variable, read the CSV file line by line, create an object, process it in this manner, I mean, where is the optimization and intuitiveness coming from? It's of no use. You can do it in C. Why do you need Python for it, right? So Python has changed the game by giving you a ready-made setup for importing data into the Python system as data frames. So Manoj, the path of the file will be given. So if you try say you say it tab. Oh, tab is an autocomplete feature in Jupyter Notebook. Okay, any function, any path, any variable which is available in your notebook will be displayed by hitting tab. So my file was residing in F drive, so I said F tab, and it will tell me this was the folder. And see, slash is coming, not backslash. So it will all pick it up automatically. Trainer, then Python training, so on. It'll keep picking up. It has also introduced codes by itself. So it's an intelligent editor. Tab autocomplete feature is there. You can also provide comments to it. Okay. Guys, can you all hear me? Okay. Yeah. Don't worry. I didn't something in the period, so you haven't missed on anything. Okay. So when we are talking about data analysis, modeling, machine learning, pandas helps fill this gap, enabling you to carry out your entire analysis workflow in Python without having to switch to a more domain specific language like R. Now, R is definitely domain specific, focuses entirely on statistical modeling and machine learning, and has core statistics implementations of everything, which is a beautiful thing in itself. If you start working in it, you really fell in love with R. Okay, but when you start working with Python, you have so much to explore and so much to connect together that the opportunities or the possibilities become endless. If you learn to use scikit-learn, pandas, numpy, you can integrate that particular model into your web programming interface of your Python website, wherever you have used a Python code to incorporate in your website. So the gluing thing, the combining thing, the injecting thing, is everything is there in Python. You know X, you will be able to connect X with Y using Z. This is how Python works. Okay, so the data structure most relevant to data manipulation and analysis workflow that pandas offer is the data frame. It is the Pythonic equivalent of R's data frame. Everything is the same. A data frame is observations and variables. Now these are keywords, and they are the same across SAS and Python. In SAS also, a data set has got observations as records and variables as columns. Okay. Now, manipulating data frames has its utility in tasks such as exploratory data analysis, data wrangling, data pre-processing, building models, and visualization. All this can be done on data frames. This is the beauty of data frames. All this can be done on data frames. Okay. See, don't worry if my voice is breaking intermittently. If you're able to view my screen, that's good enough. Okay. And if you have any questions on that, you can quickly write your question in the chat window, and I'll be happy to take up those questions. Cleaning training set. Okay, Ram, what question you have on cleaning the training set? So that is something you will be able. So Ram has a question: how can he clean the erroneous data which is there in a data frame in the training data set. So all this happens in the exploratory data analysis. All this happens in the exploratory data analysis, because first you need to know that something wrong has come up in your data, right? Once you know this, you will be able to fix it by deleting such observations, substituting them with capping values, taking care of the outliers, and a lot of other missing value imputations, and a lot of other techniques are also worked. So all this is used to clean up your data, and this is what data wrangling precisely means. In data wrangling, you do all this, but in order to do all this, you need to know whether there is an issue with your data or not. And exploratory data analysis helps you do that. Once you're done with both these steps, you can do the data processing so that you have the correct data frame at hand, and then you can build your model on top of that data frame. And if you have done all this, you will be able to use something like a matplotlib or a shiny application, or a Seaborn, or a Bouquet. So all these are visualization tools which work seamlessly with Python. So you can use these tools, have your Python output in place, and these tools will be able to interpret that output and generate nice looking graphs for you. Okay, so handles, so in data frame, handles missing data, comments, and other data issues gracefully, and does the powerlifting work for the data. Okay, now as I've shown you, in order to work on pandas, you have to import pandas as, say, any alias, say PD, and you can convert the data frame into NumPy array. But always be sure of doing that out right now. Work pandas data frame separately. So let me show you how we can directly pull up from the web page. Okay, so again, now see the beauty of Python modules, and now see why I was talking about different components glued together. Now you have a package called URL in Python, which helps you model URL lib, and will import the function URL retrieve. Okay, and we'll pass the argument to URL retrieve in driven repository, right? So let me show you the repository I have. For you to work on, and this is the this so can you all switch? I'll give it a couple of seconds. I think there is a little lag. Let it come up. Yeah. Okay. So and shift enter. Now the variable contains this URL which you want to download, the file which you want to download to your local instance. It will come to your local instance, to your local machine. So, and in the local machine, object wine.csv, right? So if this, see the star is up and the retrieve is complete. Retrieve means bringing it from the URL. Okay. So once the file has been retrieved, it is stored in right when it into a right. This was the object. Whenever such retrievals happen using URL, the default delimiter that is captured in it is semicolon, unless you explicitly provide a delimiter. If you and then you want to see those again. So this is the file that has been now imported. And what is DF now? DF is a pandas data frame. Why do I need a pandas data frame? Because I cannot work on the flat file directly, right? I have to bring it first into the Python system, and then I can start working on it. Then I can explore the data. Then I can do missing value imputation, clean the data, and then build model on that data, and then uh, bring out the results from it. Okay. So RDBMS or a flat file, but also to pull your data from the web URLs. Okay. So once you have the data, and I want you to see a quick glimpse of how do you do some visualization in Python as well using matplotlib. So suppose I have the wine quality, I do the same thing and I import the wine quality red file, and then I would like to print the first column. So in pandas, we can directly pass the URL like this. This is another way of putting data in pandas. So you assign a here, you say read CSV, and in the first argument give the variable name which you have assigned the URL, what is the separator of that file which is there on the server, and what are the column names, right? And what we are importing the most famous iris data. What is the iris data? Iris data is the data which of measurements of three varieties of flowers, which was done by Professor Fisher, who is considered to be the father of statistics, to calculate and to come up with some statistical analysis on top of that data. Okay, so it contains basically 5 columns: sepal length, sepal width, petal length, petal width, and the flower's name. There are 3 types of flowers: Virginica, Setosa, and one more. So 3 flowers and 4 measurements. So this data was captured by Fisher, and we are importing that data directly from the machine repository. See here, URL is here, pass the URL, separator is this. That data set did not contain the header, so we will provide the header, and that data set contains the header description. Know that the order of variables given in that file is this particular order. Okay, if I run this, it is now importing that file from the URL which you have just provided, and now you import the matplotlib module which you use extensively for visualization in Python. Okay, so the alias you have provided is PLT, and now have a quick look iris data set. Okay, data iris dot head. So let me, I think there's a mix up here. So let me change it. The variable, the object variables were the same. So maybe it is not overwriting properly. So there was an issue with the variable description, so it was not overwriting it properly. So whenever this is the case, change the variable name and store the object in a new fresh variable. Use a fresh variable for storing and these data frames. Okay, so the sepal length, sepal width, petal width, and species. This is how your data frame looks like. This is your data frame now, pandas data frame. What is the program? Simple frequency distribution. Okay, of anything. So suppose I want to understand for the petal width, which is this column, what is the frequency distribution? List. Now this function, where is argument to this function? Say petal width X label. So what is the X label and what is the Y label? Y label is counts. Okay, and then I say and today I don't know. This is an old notebook. So this plot is different now. Now what I've done this Jupyter notebook. This is another module which helps make your graphs look nice, smooth, much more interesting than a plain matplotlib graph. If you've worked in R, this is something like using ggviz instead of 2. Are you getting this point? So in the visualization space, there is a lot of development happening. So you had matplotlib, you had simple graphing capabilities in Python earlier. Now you have matplotlib, and now you have bouquet. Now you have seaborn. So the level of visualization, the the appeal of the graphs, the split, the breakup, and everything has increased and improved dramatically. So that is why I am emphasizing that as a data scientist, you should also be well versed with data visualization components as well. Okay, you cannot skip out that part, because I can tell you from my personal experience, if you develop a machine learning model and if you deploy it, at the end of the day, the business users always ask you for, can we have a visualization in place? I want to see how in real time, or say in a fixed duration, how the users are interacting, or how the key metrics are changing. Suppose somebody is some users are signing up for your website, so they want to see in real time how that this is changing, if the users are changing their accounts, signing in, signing out, whatever is happening. So unless you have a visualization logic in place, the end user will never be able to see it. He won't go to the flat files and open up those flat files and see the records which are coming up, right? Or the databases and query those databases to see what records are coming up, or what is the output coming up. So this is all a part of the visualization interface of your installation itself, and this is a very real possibility. Same thing holds true for R. Whatever I'm saying now for Python, same thing holds true for R. They are in this context, they are both siblings, work in the same way. So suppose you want a library, a module called seaborn. Now this worked because I've installed it, okay, from my end. Otherwise, if you work on a raw Jupyter notebook, you might not find the seaborn module. So if you want to install that seaborn module, what you can use the exclamation mark, and as soon as you give an exclamation mark, the Jupyter notebook uh, un understands that you want to submit this statement on the Python shell, and the Python shell understands pip install command. Pip install, okay, pip install, and then seaborn. So it will say, okay, I'm collecting the seaborn components, I've downloaded it, tar, building it, doing this, successfully built, installed. So this is how you can install modules and packages in your Jupyter notebook without even leaving your notebook, right? You haven't switched from your notebook up till now. This is how intuitive, easy to use and comprehensive this application is. Are you able to understand and appreciate? Okay, so you can install the modules right here in the Jupyter notebook. You can this, so see those attributes to the graph which you are trying to plot. You can always define, you can always provide those attributes and parameters to the graph, and the graph will come up exactly as you want. Right now I'm just saying plot this petal width and label the x-axis as petal width and y as count, nothing else. So it is defaulting using its own knowledge to fill up the if you have any doubts what we have discussed, anything you are not sure of. Okay, great. So this brings us to the final milestone of developing a machine learning model in Python, and the module which we'll be using is scit-learn. So scit-learn, NumPy, pandas, all these are packaged in Anaconda setup itself. You don't have to download it from the Python org website, and you don't have to do pip install for all that. However, if you working on PyCharm or say some other IDE and you just have plain Python installed, you'll have to download and install all these modules from the Python org website or the NumPy and SciPy websites. So Anaconda saves you the effort there. Now we'll work on the iris dataset. As I told you, it contains sepal length in centimeter, sepal width in centimeter, petal length in centimeter, petal width in centimeter, and finally the class or the category of the flower. So you have iris setosa category, species of flower, iris versicolor, and iris virginica. Okay, these are the three category of flowers. What was this exercise? This exercise was basis the sepal length, sepal width, petal width. Can you classify any random flower belonging to the iris family into one of these three categories? This is a simple plain classification problem. Okay, we have already downloaded the data, and now we will start working on that data. Before working on that data set and applying our scikit-learn functions, a brief overview of the terminology that is used here. So every row is an observation, we just discussed that, and every column in your data set or data frame is called a feature. That's just a terminology, means the same thing. Now that is why I was saying don't get bogged down or confused or discouraged by the various jargons which are used. Jargons are just because all those terms or terminologies have come up from different schools of thought, otherwise they all mean the same thing. So column is a feature. Okay, it can be a predictor, it can be a input variable, whatever you want to call it. So here we call it a feature. So once you've imported an object from sklearn, you can see its data, its features, its target variable. So I can go ahead and print iris data scikit-learn as scikit-learn as sklearn. No, this doesn't work. So the module is called scikit-learn, but it gets imported as sklearn, so you will directly say import sklearn. That's it. If you have scikit-learn installed, that means you will install this package, this module, but the moment you want to import it, you can say and it will work. The alias okay. So import sklearn, and from sklearn.datasets import load iris. Now, what is the difference between these two statements? Does anyone want to take a shot at this? What is the difference between these two statements? Okay, So the first statement will bring and load all the functions, all the methods which are available in scit-learn module, which is not recommended. It is the machine learning library. It has a lot of functions which are computationally intensive. All these functions to be loaded in real time is not advisable. Rather, you should bring up only those functions, data sets, or methods which you really need to work on in this particular instance of the Jupyter notebook. So from sklearn.datasets, you will import the dataset called load iris and you will hit enter. The iris dataset is now loaded on. Okay. From where? From the sklearn data, the sklearn module. It contains datasets also, as like other applications. You have default or inbuilt datasets in R, inbuilt datasets in SAS, inbuilt datasets in other applications. Similarly, you have this load iris dataset in sklearn.datasets library in scikit-learn. Okay. So in order to load that load iris, it means you're now loading the dataset into this. And if you want the type of that, it is sklearn.datasets.base bunch. It comes up as a bunch. I'll tell you why it is a bunch, but it is not a data frame. It comes up as an array. It has sepal length and library target. Uh, the target. Now you see there are numbers in the target. However, I told you there are three categories of flowers. So the point here is the target category is mapped to a particular species of flower. You can see there are 0, 1 and 2. So these, if you want to know those categories, those classes, you can say Setosa versica and Vomica are the names of the species of those iris flowers. NumPy, any numerical matrix or any numerical storage of data will be happening. It will be happening in NumPy. Okay. Similarly, target, that is why the target was showing up as numbers, because it was show by defining the. So couple of things we need to ensure before we run the machine learning algorithms from the scikit-learn on the data. The first thing is the feature and response, right? So these are scikit-learn. They are the variables which you are trying to, what the target. variable. Okay. The scit-learn convention is to store features data in an object. Context is used to and and small because we want capital X type, right, is the column names as well as the value names. But Y, which is I target want to run a straight, which helps data is unknown data into data. Parameters which you can define here. You will okay. And now you want to see of more parameters, but you have provided only one, so the rest will be defaulted by the Python system itself. Okay. Leave size means it's trying to prove it. Metric, it is to a decision. Metric parameters, number of neighbor to weights is uniform and everything. The standard way to run your model on the training data. So right now I have not split the data into test and train. I just want to share this approach with you. Okay. So with X so that the training is test data I passed to it. What will be the result of that model? So I'll this is a random because I wanted to randomly pick 10 values from that training data itself and run this model predict function. Okay, KNN. Now KNN is the same object which is holding this neighbor classifier result dot predict and then pass the test vector to it. Okay, test array to it, and it will return back the vector to you saying which category of the flower does this particular record belongs to. Okay, so this is how you will run entire machine learning model in scikit-learn leveraging the power of pandas, numpy, and of course all this is done on Jupyter notebook. Okay, now is it the end in Python? No, it's not. there is much more beyond that, and there is so much depth in this. This is just the surface that we have scratched. There is much more beyond this, much more in depth. Okay. And somebody asked me about scalability. Where does big data come into the picture? So big data comes into the picture very realistically and in real time. And when you face such situations, you have to take basis. Now, the you are in a position to either work on the localized instance and develop your codes and work on machine learning algorithms on a small data set, or if it scales up in your level capabilities, the shell and work on that shell using the Python Lambda function and other capabilities which are included in the Spark shell. There is a lot more development and exciting things happening in the Python community, which enable the developer to find solutions to problems which keep on evolving as and when the environment progresses. You know, the entire ecosystem is evolving. So the Python community is also evolving along with it. And it always makes sense if you are leveraging your knowledge of Python to keep pace with all this. Okay, so I'll quickly pick up a few questions which people have asked. Yeah, of course, to learn statistics and maths, there are a couple of books I'll share with the people here. They'll forward them to you. You have to go through that content, and there are only few things which you must know in a pretty solid way in statistics and mathematics. Rest all is something that it's good to know, but if you don't know it, it's not that you won't be able to work on it, right? Classifiers different from models. So no, a classification model will be there. So model is a generic term. It means you have built something that was trained on the training data set, and now you are giving it some test data which was not seen by it earlier, and it is churning out or estimating the results basis its knowledge. Model means this. So classification is a type of machine learning algorithm which helps you build such models. Regression is also such an algorithm which helps you build models. Neural network is also an algorithm which helps you build models. Deep learning is also an algorithm which helps you build models. This is how it works. For data science, there is no one clear-cut source for material, and this is why this is such a distributed and scattered topic. There is no one material for it. It's a collection and collage of everything. So what I would recommend is you should take a data science course to understand what all needs to be done in data science, because it has various disconnected pieces which you have to connect together, and then you'll be able to understand what your responsibilities are. Thank you, Chandrakala, for the feedback. So you can reach out to the folks at Aurelius. They'll let me know if you have any issues, any concerns, or any other sessions you want to attend. Okay, this session was primarily intended to clear any doubts or concerns you have regarding data science with Python. Okay, so I hope it was a session which met your objectives, and I'll close off now. Thank you all so much for being a part of this. Thank you.
Thank you, Nitin, for such a wonderful session. Thank you, Nitin, for such a wonderful session. And thank you all for attending today's webinar. Your participation was important to us. We'll be coming up with a number of free webinars on various topics for which we will be keep you updated. So if one of your friend wants to get register with us, or if for any further queries, you can write us at livesessions@aurelius.in. And I'll repeat it again. It is livesessions@aurelius.in. Thank you so much. Have a good day.